little more about the ensemble techniques. Okay, we have already said that the random forest uses ensemble technique, which is called bagging, but there are some other ensemble techniques like boosting and stacking as well, and we'll talk a little more about it. So bagging bagging is used by random forest, or random forest is an ensemble technique which is bagging. And one more time, let's say why we call it a random forest. We call it a random forest because the bootstrap, we create bootstrap data set from the training data, right? And then bootstrap data sets are created randomly. We have already talked about it. So each tree is trained using a random sample with replacement from the training data set. Also, there's one more reason why it's called random. That's when training of individual trees, then random subsets of features are used for searching for splits. If you remember, we do splits using information gain or Gini index, and here random sample subset of features are used for this. So two nearby trees will not always use the same features to split. So they can use randomly selected different features. So this can reduce the correlations among the trees in the random forest and improve the predictive performance. So you want to include as much randomization as possible. Okay, so now in the second step, we said that the unpruned decision trees fit on each bootstrap data set. So the trees are unpruned here, so they can go as deep they want to go, and this is not controlled. Okay, but the trees are trained parallelly. Each of such trees are called weak learners, and they are trained in parallel. So bagging is a parallel method. Okay, and so at the end we do a simple majority voting or averaging of the predictions to find the final decision out of the bagging algorithm. And this is good for high variance and low bias type of data set. But what happens when we have a low variance but high bias type of data set? We can use boosting method, which is a sequential method compared to the bagging, which is weak learners are working in parallel. So for boosting, so they focus on classifying instances which are hard. So this is something like, let's say there are many students in a class, and there are, let's say, some student who are not performing in that same environment as well as the other students. So what we do, we help those students with special office hours, special help sessions, or some extra assignments or some other type of help, so to boost their performance. So this is exactly boosting. Okay, so there will be a series of models which will be constructed, and with each new model, so it's a sequential process, with each new model iteration, the weights of the misclassified data, that means which were failed or which are hard to classify in the previous model, will be increased. That means the weights of those misclassified model will be increased, so that in the next iteration they get more focus in classifying. And so then this redistribution of weights helps to focus on those hard to categorize or hard to classify instances. And there are many such boosting algorithms like adaptive boosting or AdaBoost, which is very famous, gradient boosting, XGBoost or extreme gradient boosting, stochastic gradient boosting, linear programming boosting or LP boosting, total boosting, Brown boosting. There are many such boosting algorithms. And please understand, this ensemble techniques like bagging, boosting, they are extremely used in industry and by researchers, because their performances are better than just standalone classifiers. So this is bagging and boosting. Random forest, you will always see that they are giving the best accuracy among multiple different models you are trying. So now the third one is stacking. This is also an ensemble techniques, and this is they use the unchanged training data set. Like in bagging, we divide the data set and create multiple bootstrap data set. In stacking, we just use the same data set and give it to different ML algorithms. But sometime, in some variations of stacking, the data set is created multiple kind of copies or variations, and then they are used. So at the second level, what we do, different machine learning algorithms are given to different ensemble members. And here you see, this is also called the level 0 model. So see, this is the main data set you have. Consider that it's not divided, it's just the unchanged data set, and we're giving to multiple different models. Now here model 1, model 2 until model n, they train in parallel and they are called level 0 models. And the most important part is that they can be different models, okay, different models. So heterogeneous weak learners, we also call them. So, and they work in parallel. So they can be decision tree, they can be SVM, they can be neural network at the same time. The first one can be DT, the second one can be SVM, third one can be neural network, and like that. And their outcomes go to another model, we call it also meta model. It's also trained based on the outcomes of this. And this is called a meta learner, all are level 1 model. These are level 0 and this is level 1. Okay, so this model is also trained, but sometimes for the sake of simplicity, what we do, we just use some linear linear model like simple linear regression or logistic regression for classification kind of tasks, and simple linear regression for continuous variable prediction. And you see this. So why we use heterogeneous weak learners, why we use SVM, decision tree, neural network, different types of models, because they have different assumptions. They're not biased on something. Okay, they have different types of assumptions, and they have less correlated prediction errors. So one does not depend on the other. So in case of bagging, what happens? Everyone is a decision tree. So there is a chance that they are kind of carrying the bias a little bit, and because everyone is a decision tree and have one has similar type of outcomes or similar type of decision making. But here everyone is a different algorithm, so they have less correlated prediction error. So we have talked about 3 different types of ensemble techniques: bagging or bootstrap aggregation, boosting and stacking. And we'll probably not talk into the details of every type of the ADA boost, gradient boost, but I strongly encourage you to look into them, because they produce very good performance, and they are used in lots in the industry and also in interviews.